Hello everyone, my name is Anishana and today my topic is Kubernetes Probes. First, we will try to understand what are Kubernetes Probes. After that, we will deep dive into type of props. Further, we will talk about how to implement these props and in the end, we will do lab. This is the basic slide for your reference. So we have four topics. Let's discuss the first topic that is understanding Kubernetes prop. The first topic is what are props? Props in Kubernetes are powerful tool used to perform health checks on containers, ensuring that applications run smoothly and reliably by monitoring their operation states. After that role of prop, sometime it may ask in the interview, what are the role of props in container orchestrations? Kubernetes use props to manage container lifecycle events effectively, such as restarting failed containers, preventing traffic to unready containers, and delaying startup until initial containers are met. So these are the rule of props. And the last is benefit of using props. Implementing props can significantly increase the resilience and availability of services in Kubernetes clusters by automatically recovering from failure states and enhancing load balancing. Now, technically, why we need props? Pod phases. There are different phases of Kubernetes pods lifecycle, from pending through running to success or field, and how props interact with these phases. Inside pods, containers are running. Thus, it would be worth to understand the container transitions between states like waiting, running, terminated, and the role of props play in these transitions. Importance of health checks. Health checks are crucial for maintaining service availability and reliability in dynamic container environment. And Kubernetes props are the primary mechanism for performing these checks. Now, phases of ports, container transition, and health checks. We understand that props help us to work on these stages, but still not very much clear, to be very honest, right? So let's deep dive into the type of props where we get more information. In Kubernetes, there are three types of props for container: liveness, readiness, and startup. Let's deep dive into the first one, that is liveness props. It tells the Kubernetes that the containers need a restart. Now the question comes into our mind that why we need a restart. Well, sometimes there is a deadlock in the cluster and container cannot restart itself. Then liveness props tell Kubernetes that this container need a restart. Another example would be we have a Nginx web server and it is running fine, meaning Nginx services are up and running. However, it returns HTTP return code. From application point of view, it is not acceptable at all. In this case, we can set our liveness prop to instruct Kubernetes to restart this container, right? So this is the benefit of restarting of container. The official definition of liveness props is the kubelet use liveness props to know when to restart a container. For an example, liveness props could catch a deadlock when an application is running but unable to make progress. Restarting a container in such a state can help to make the application more available despite bug, right? So this is the benefit of using liveness props. Now, how we can define these liveness props? We can define these liveness prop with the help of command line that we use exec. The other way is HTTP request. The third is TCP liveness props. And the fourth one is gRPC liveness props. So this is the service. So we will send the request to the service, and if the service is up, it means my container is up and running. If service is returning some 500 return code, then it means that we need a restart of container, right? Let's talk about one by one on these. What are these? So I will cover all these four in the end of this session, don't worry. So let's focus on readiness probe. The kubelet use readiness probe to know when a container is ready to accept traffic. A pod is considered ready when all its containers are ready. One use of this signal is to control which pod are used as a backend of services. When a pod is not ready, it removes the pod IP address from the endpoints of all servers. To explain more, as we are aware that we expose the deployment through services. We have different type of services such as cluster IP, node pod, and load balancer. When we create these services, we mention the pod IP address in the endpoints, right? If readiness props tell the kubelet that this container is not ready, then kubelet will remove this pod IP address from the endpoint. To conclude, this prop we use to ensure that container is ready to accept the traffic. Please bear in mind that this prop will not going to restart this container in any cost. We can configure these props like we did for liveness prop. We will deep dive into this in our lab section. Don't worry. The last prop is startup props. The kubelet use startup prop to know when a container application has started. If such a prop is configured, liveness and readiness prop do not start until it succeeds, making sure those props don't interfere with the application startup. This can be used to adopt liveness check on slow starting container, avoiding them getting killed by the kubelet before they are up and running, right? Let's understand with the help of one example. We have defined multiple commands in the pod manifest file and it takes some time to finish it. Once this command executed well, then only our application will be considered start. So we can configure our props to check if all these command is finished or not. Once it finished successfully, then only readiness prop or liveness prop can start their job. If we created the liveness and readiness prop, perhaps there may be some confusion about these props. Let's check their difference, then we get to know what are these three props: liveness, readiness, and startup. When a container need a restart, this prop check the application is running as expected in the container. If not, then it will ask kubelet to restart the container. When a container is ready to start accepting traffic, this prop checks if application is ready to serve the traffic or not. When an application inside the container has started, this prop check if command mentioned in the manifest file is completed or backend database services are up or not, and so on. Right? It does not wait for readiness prop to succeed for liveness. And for readiness, it check dependencies like database connection and other services that your container is depending. Once this prop success, then only liveness or readiness prop will be started. Liveness, it run on the container during its whole life cycle. It means that every 5 second or 10 second, whatever we have defined, it checks every time. Same as it is for readiness prop, it runs on container during its whole life cycle. This is what I have written here. And startup props, it run only when pod started. If the request fail, it will restart the container. Until the request return successful, it won't serve any traffic. It will not going to restart any container. And until its success, none of the props start. It means that liveness and readiness prop will not start until this startup prop started. Now we have completed all these three props: liveness props, readiness, and startup props. Let's deep dive into how we can configure these liveness props. Liveness props we can achieve with the help of http get, with the help of execute command, tcp socket, and service, grpc service. In HTTP GET, we can configure liveness prop with the help of HTTP GET. Here, the HTTP GET and the first is path. This parameter is a health endpoint of application. If this point is not clear, no worries. When I will configure one port, then you will understand what is this endpoint. For now, you can just remember that this path is a health point. Port, we have defined the port number on which our container application is running. In this case, my container application is running on 8080 port number. Initial delay second. The first time when liveness probe will test the application. It does not wait for readiness probe to succeed. If you want to wait before executing a liveness probe, you should use initial delay second or startup probe. The second one is period second. It means regular interval after the application startup. So it means here it will check every 10 seconds. And initial delay second is it will wait for 15 seconds once the my container is up. And the last is failure threshold. The default value is 3. After the failure, a container is classified as failed. And here I have defined one. It means that if a single point it failed, it will restart the container. This is the reason it says that you need to whenever you are defining the liveness probe, you have to be very much careful that how much these threshold value will be. Otherwise, your pod will be restart again and again. Let's go to the second one, that is command, that is execute. And here the syntax is exec. Command is cat temp healthy. In this case, this liveness probe will check only this file. It will cat this file. If this file is present, it means that it consider as a healthy container. If this file not exist, then it will restart the container. Obviously, this is an example, but you can configure as per your requirement. Let's move to the our third one, that is TCP socket. In this configuration, we define here TCP socket and the port number is 8080. It will send the traffic on this port number 8080 and rest of the other variables are same. I'm not going to explain all these values again, but for you this is clear. And the last one is GCP. And here we have configured the service on this port number 2379. That's it. So it will send the request to 2379 port number. If this service is up and running, then it will consider as good. Otherwise, it will restart the container. So in this case, if your application is implemented the gRPC health check service protocol, then you can use this deployment. This is for liveness props. So these are the four key parameters that we can use. For readiness, again, all these are same. But in this scenario, it will not going to restart the container, but it will block the traffic until it's get healthy. All parameters are same except readiness here. If you want to learn more about these props, then you can directly log in into Kubernetes.io webpage. You may visit this webpage and I will also add the link in my description of this video so you can check it from there. Implementing props with example. So let's do the lab. In order to proceed the lab, I have already logged in into my GitHub page and here I need to click on Kubernetes. And if I scroll down, I will observe that 23 props is the directory over here. So let's proceed with the first one, that is liveness prop. As of now, we understand that we can deploy this liveness prop with the help of these four parameters. Let's proceed with this first HTTP and this. We will going to create one pod, Nginx pod, and for that we need to modify the configuration, right? For that reason, I have just already created one configuration file for Nginx. This one is the default one. And here I have added one more parameters, that is server. Location is health. This is the endpoint path. I have mentioned in my PPT here. This path is health, and same name I have added here. And access log is off and return is 200. That's it. This extra configuration I have saved on one file and it will be on my local node default.conf. Let me copy over here. Let me go to one directory here, data, and inside this, I don't have anything here. That's a good thing. Paste over here and let me create one more index.html, but here we are just copy create one file that is helz. That's it. But actually it is index.html. Clear the window here and paste it over here. Now if I do lsltr, I should see two files are here. Now we need to create the config map so that we can have all these detail in our config map, and that config map that we can use inside the pod manifest file. Let me copy here. I have already created one video and uploaded on my YouTube channel for config map, so I'm not going to share what is this from literal. It is also created here. That's great. Now in the pod manifest file, this is kind is pod, and the name of this pod is liveness stdp. And here we have two volume mount, that is one for config and the other one is for health. This is what we created previously, health and nginx.conf. And this is the mount path. The config file, the nginx configuration file will be hosted or mounted in this directory. However, for the nginx health page that we created, this page will have only one line. So this will mounted in this directory here. Further, we have defined the liveness prop, and here we are using http get and the path is health and port number is 80. Initial delay second is 2, blah blah blah. And here in the end we have mentioned the volume config, and this is read from this config map nginx-conf, and this health, and it is read from this config map. I hope you understand all these things we have already covered. If you have watched my videos, then I don't think so that you have any issue with that. Now create this resource pod. It's created now, and I should see this pod should be running. Yeah, this is the case. We can also describe this pod with the help of describe. Show you here. It says pulling image nginx successfully pulled, and it container is started, created and then started. Let me clear the window here. Use the W minus W watch option to see the progress of this pod. Actually, we are going to stop the Nginx services and will observe the behavior of this pod. It should restart the pod again. Let me open a duplicate session for this so that I can show you. Okay, now I have two terminals here. Okay, so let me copy this command here, and it should watch the current state of my pod here. It is running here, and I have already opened a second terminal here. Now in this command, I'm going to shut down the nginx services here. The way that we can use terminated, and now it is completed and it's again running. It means that it restart the container. We should output like this: running here must be restart. If this is the case, then we have done the lab for liveness http props successfully. Now let's proceed for the second one, that is execute here. And here we have all the things are same here. We are using bin sh, and the command is going to create is this one, and after 30 second it will sleep for 30 second, and then after 30 second it will going to remove this file and then wait for 600 second. It means that first our liveness pod will be up because this is time healthy. This file will be created and it will wait for 30 second. After that it remove this file. It means that initial delay second is 5, period is 5 second. After 30 second completed, once it check, it sees that this file is not here. So it will restart the container again and again until 600 second. Let me show you here. Control C here, create this pod. It is also created here. You can get this pod. Exit pod is running. We can also describe that this pod is running, blah blah blah. Started, no issue. You have observed here. And let me tell you that for this BGBox image, not Nginx. Now here, after some time, after 30 seconds, if I use this command, I should see that this is rebooted here. Let me show you. Liveness failed. After 30 seconds, it deleted the file and it will remain for 600 seconds. After that, this port will be created once it create the files again. This is how we can achieve here. That's it. After 600 seconds, this pod will be up. And this is what I have mentioned here. You will observe that this pod is restarted. The reason behind is that in the command we mentioned that touch blah blah blah. It means first it will create a file and wait for 30 seconds. Then it will delete this file. This prop check. If this file is not present, then it restart the pod container, not pod. If this is the case, then we have completed this task successfully. Now both are running. No such file and directory. This is what it is mentioned here. But now my pod is running. And if we can check here, 8 second, container liveness field, liveness prop will be restarted. And after 30 seconds, if we wait, it will again fail and it will restart the container again. Started container liveness 1 second before. This is how we can achieve here. Let's proceed for the third one, that is TCP. How we can achieve here. So it will send the request to this port number, that is port number 80 here. Our Nginx service is running on port number 80, so this liveness prop can reach to port number 80. And here I'm using the previous pod, but the liveness configuration I have just changed. That's it. Copy this YAML file here, paste it over here to the window. This YAML file, kubectl get pods. Let's check. Third pod is running. Yeah, it is also running. Check the status. I have already checked. It is running, and the restart is 0 here. You see, the restart is 0. This is what we need to observe here. Now again in the second terminal I'm going to stop this and it should restart the pod. Let me check here, please, minus w. Now the restart is 0, and if I execute this command liveness tcp, if I stop the nginx service, I should see it is completed and now it is running again and the restart value is 1 here. A simple restart can bring our container in healthy state. This is the leave of this props. It's for your references here. Official link page for gRPC services. You can check this website if you want. In this, we can check directly if the service is running on this configured pod here. And here I used the same pod YAML file, manifest file, and it is running on port number 80. Let me copy here. Sometime it works, sometime not. Be very honest. Control C, applied, and now we We can check if my pod is running or not. It is running and the restart count is 0. Now let me reload the service. If I reload the service, I should see the restart. However, for Liveness, TCP and HTTP, I will not going to see any restart for reload the services here. Clear the window here and paste it over here. I'm not going to hit enter. Let me check here with minus W option here. One is restarted because it's my 80 service is not very efficiently working on a port number 80. So for that reason, it is restarting by its automatically. Now I see restart one, so it is restarted, so it's not see anything here. Now I can see that two restart is here. It's happened because of this reloading of services. That's it. From this lab, we get to know that if we stop the Nginx services, container will be restart, and when it start the Nginx services also. And sometime it is helpful for us for auto healing of application. How to clear the lab? Copy all the commands here and paste it at terminal. That's it. It will delete the pods that we created earlier, 4 pods, and then delete the files that we created, and also it will going to delete the config map that we created here. It takes some time. It's okay. Now everything is deleted here. If I do ls space ltr, so everything is deleted. Config map is also deleted. I believe, yeah, config map is also deleted here. Now let's move to our second topic, that is readiness props. This is also can configure 4 types here, and I believe that you can go ahead with this lab. I'm not going to do it. It's totally same, but here we just modify the value from liveness to readiness. That's it. Okay, we can add liveness and readiness props in a single code manifest file. Let's have a look into this example. This is the default Nginx configuration file here. Let me copy and paste it over here. After that, a single web page. Obviously, we need to create the config map for both of these files. We created two config map here. And now in this port manifest file, we have liveness probe and readiness probe, and both having the same path, that is path health z that we created. Rest of the other things are same here. Let me copy this manifest file here and paste it over the terminal. Control L, you can use shortcut to clear the window. After that, create this pod. We can check the status of this pod with the help of kubectl cat. It takes some time, and we can also describe this command here. Let me copy here, and what is written here that we can use w minus w for watch, and here again we will going to stop the nginx services here. Let me execute once again. Now it is running. We can describe this port with the help of tail, and now everything is running fine. I don't see any issue here. Let's use minus w. Now I'm going to stop the nginx service here in this terminal. I should see that this liveness prop restarted the container. Now the restart count is 1 here. That's it. And we can clear the lab with the help of these commands here. All these commands are well tested, and I'm also executing these commands from this GitHub repository. So you can use these commands. If you're still watching my video, then please like and subscribe to my channel and press the bell icon button. Now go back here. And the last one is startup prop. Click here. We can employ readiness and liveness probe for our containers. But what if we have a container that hosts an application such as a legacy application which needs a more time just to start up. In this situation, we do not have a faulty application. We just have a slow starting application. Implementing a liveness props would put it in the loop where the container is restarting before completing the startup props each time, right? So for that reason, Kubernetes introduced the startup props, and we can define these startup props with the help of these four parameters, whatever it suits for you. Here I'm just taking one example with the S3P. It's pretty much easy. I'm just going to create these files again here, and every time I'm creating these files, because you never knows that which user want to do which lab, right? For that reason, I'm deleting the lab at the end and creating the prerequisites in the beginning of the lab. Won't take too much time here. In the startup props, what we have defined here, liveness prop we have defined here, and here we have defined the startup props. On the top of that, we can also define the readiness prop if you wish. So ready, if we define the readiness prop here, and if this page is not available or it Nginx service is stopped, then readiness prop will ask kubelet to remove this port IP address from the endpoint. That's it. And this startup prop has the same value that we have defined in the liveness prop here. Just for an example here, in production, you may have different values and different criterias, but this is just for your information that how we can create the startup props here. And it takes some time for the ready. It is running, but it is not ready. Now it is ready. Now again, we are using this command here, W, and on the next terminal, we will stop the Nginx services here to see if we have, if our liveness prop will going to restart this container or not. Now it is, now it restarted. What we understand from the startup prop is that until the startup props start, the liveness and readiness prop will not initiate it. In nutshell, startup prop will start first, and after that, liveness and readiness props will start doing their job. That's it. Let me clear this window here. Everything is good. Look, that's it for this lab. And let me tell you that you will get one question in CKAD exam from this topic. Thank you very much, guys. Please like and subscribe to my channel and share my video with your friends and colleagues so that it can help me also. Thank you. Bye bye.